learning objectives, and key concepts. Explain the fundamental concepts of network security. Network security in the 7 domains of typical IT infrastructure. Network security goals, internal and external network issues, network security components used to mitigate threats throughout the IT infrastructure, the basics of transition control protocol and internet protocol, commonly referred to as TCP. So the question is, what is network security? It's the control of unwanted intrusion into, use of, or damage to communications on a computer network. This includes monitoring for abuses, looking for protocol errors, blocking non-approved transmissions, responding to problems promptly and accurately. What is network security? Continued. Network security also supports essential communications necessary to the organization's mission and goals, avoids unapproved use of resources, ensures the integrity of information traversing the network, prevents unauthorized access and actions, supports desirable activities, accessing customer records or managing inventory, enables quick and easy access to resources and services for users, supports the organization's mission and goals, enforces the organization's network security policies, supports workers in their jobs, and protects against compromise, and maintains high performance and keeps cost to a minimum. A key concept in network security is trust. What is trust? Trust is confidence in your expectation that others will act in your best interest, the belief that others are trustworthy. With computers and networks, trust is confidence that other users will act in accordance with your organization, security rules, and corporate mission and vision. Trust also includes permission, authorization to access an asset, privilege, the ability granted on a network. A common example of third-party trust system is the use of digital certificates that a public certificate authority issues. As shown in the figure, a user communicates with a web e-commerce server. The user does not initially know whether a web server is what it claims to be or if someone is spoofing its identity. Once the user examines the digital certificate issued to the web server from a certificate of authority, the user can trust that the identity of the website is valid. This occurs because both the user and the website have a common trustworthy third party that each know. Who or what is trustworthy? Determining who or what is trustworthy is an ongoing activity. Offer trust to others on a conditional basis. May offer trust based on the reputation of a third party. Conditional trust changes based on adherence to or violation of desired or prescribed behaviors. May withhold trust when rules are violated. Trust stems from actions in the past. It can grow based on future behaviors. Trust is subjective, tentative, and changes over time. What are security objectives? Security objectives are goals an organization strives to achieve through its security efforts. There are 3 primary security objectives, which are commonly referred to as the CIA triangle: confidentiality, integrity, availability. Confidentiality speaks to privacy. Integrity speaks to non-repudiation, meaning a sender cannot deny they received a transmission. Availability equates to uptime. Confidentiality is protection against unauthorized access while providing authorized users access to resources without obstruction. Integrity is the protection against unauthorized changes while allowing for authorized changes performed by authorized users. Availability, protection against downtime, loss of data, and blocked access while providing consistent uptime, protecting data, and supporting authorized access to resources. Authentication is proof or verification of a user's identity before granting access to a secured area. Authorization or access control is controlling what users are allowed and not allowed to do. May include discretionary access control known as DAC, mandatory access control, which is MAC or MAC, and role-based access control, RBAC, and others. It restricts access based on the need to know and users' job descriptions. Non-repudiation, the security principle that prevents a user from being able to deny having performed an action. Privacy protects the confidentiality, integrity, and availability of personal, identifiable, or sensitive data. What is security? It's what are you trying to protect? Are you trying to protect an asset? Anything you want to protect? Anything used to conduct business? Assets of high concern are usually business and personal data. What causes network security violations? Accidents, ignorance, and hackers. 7 domains of typical IT infrastructure. The 7 domains are user domain, which is where the users live. Workstation domain, that's where your hardware, your laptops and desktops sit. The LAN domain, local area network, and those could be internal servers, hubs, switches. Local area network to WAN domain, which is local area network, to wide area network, which is layer 3, routers and firewalls. Your WAN domain is connecting out to an ISP through different technologies. Your systems application domain is where your data centers are typically where those house mainframes, data center servers that contain applications and web servers. Remote access domain is your VPNs, and those could be inbound or out of bound with your network. User domain refers to actual users. And part of that is an acceptable use policy is required prior to users being granted access to an organization's IT infrastructure. Should focus on training, strong authentication, granular authorization, and detailed accounting, which is another common security term you will hear most often, which is called AAA, authentication, authorization, and accounting. Also, user domain is social engineering. A hacker can attack against people that attempts to fool people through clever wording, lying, misdirection, relationship manipulation, fear, psychological tricks, and confidence games. Workstation domain refers to the end-user desktop device such as a desktop computer, laptop, voice over IP protocol, or VoIP telephone, or other endpoint devices. Workstation device security countermeasures to maintain the integrity of the device can be antivirus, anti-spyware, vulnerability software patch management. Targets in this domain are workstations, clients, and standalone home systems. The LAN domain, local area network, refers to the physical and logical local area network. Technologies used to support workstations connectivity to the organization's network infrastructure. LANs consist of dozens to thousands of hosts. Protocols addressing topology and communication encryption provide security. Private LANs are common targets of attack. LAN to WAN domain refers to the organization's inter-networking and interconnectivity points between the LAN and the LAN network infrastructures. Security monitoring devices include routers, firewalls, switches, proxies, DMZs, which are called demilitarized zones, intrusion detections, which are IDS, intrusion prevention systems, which are IPS, and communication encryption. Targets in this domain are WAN connections between LAN connections, transition interfaces between a private LAN and a WAN connection. The WAN domain is typically the internet. Remote locations require a wide area network for interconnection. WAN's connectivity is frequently outsourced to service providers. WAN domains including networks such as an ATM or frame relay owned by a telco or a carrier network company that leases access to corporations, routers, circuits, switches, firewalls, and equivalent gear to remote locations, protocol selection addressing schemes, and communication encryption. Other MPLS and SD-WAN, or other types of WAN connections. Targets can be WAN connections between LAN connections, especially those controlled by third-party entities. Remote access domain refers to the authorized and authenticated remote access procedures for users to remotely access an organization's IT infrastructures, systems, and data. The target is remote access. Remote access solutions are encrypted remote browser or SSL connections, encrypted virtual private network tunnels, which will be IPsec tunnels. System application domains refers to the hardware, operating system, software, database software, client-server applications, and data that are typically housed in an organization's data center and/or computer rooms. The targets are server hosting applications, virtualized systems or databases, computing power of the servers, and data on the servers. Important security concerns is network design, and here's your AAA again, authentication, authorization, and accounting. Goals of network security. They are to ensure the confidentiality of resources, protect the integrity of data, maintain the availability of the IT infrastructure, ensure the privacy of personally identifiable data, they'll call that PID, enforce access control, sometimes referred to as NAC or Network Access Control, monitor an IT environment for violations of policy, support business tasks and overall mission of the organization. How can you measure the success of network security? Organizations measure the success by how well the stated security goals are accomplished, how well security standards are maintained. Good network security relies on interweaving of multiple effective security components, requires consistent vigilance. Security is an ongoing effort that consistently changes to meet the challenge of new threats, requires network security professionals to continually learn and adapt. Why are written network security policies important? What identifies most important tasks? It provides a common reference point, serves as a measuring tool, allows you to track progress, validates what you do, and defines what you still need to do, and guides you in how to repair the infrastructure. Planning for the worst. How do we respond? Respond to all failures of security breaches to minimize damage, cost, and downtime. How do we contain it? We contain threats to prevent them from spreading or affecting other areas of the infrastructure. Repair. How we must repair damage promptly to return systems to normal status quickly and efficiently. Let's identify who is responsible for network security. If you're in a senior management role, senior management have the ultimate and final responsibility for security. Must ensure the creation of a written security policy that all personnel understand and follow, assigns the responsibility for designing, writing, and executing the security plan infrastructure. Security staff manages all assets, system vulnerabilities, imminent threats, and pertinent defenses, designs, executes, and maintains security throughout the organization. Managers and supervisors ensure employees have the tools and resources to accomplish their work, ensure workers are trained and possess the necessary skills and known procedures. Network administrators manage the organization's computer resources and ensure that resources are functional and available for use. Workers are the network users and operators. Do the work the business needs to accomplish, create products, provide services, perform tasks, input data, response to queries, and much more. Auditors watch for problems and violations, investigate the network, looking for noncompliance with the written security policy. Watch activities of systems and users to look for violations, trends towards bottleneck, and attempts to perform violations. Enhancing the security of wired versus wireless LAN infrastructures. You can protect wired networks by not connecting them to the internet, which is lack of external connectivity creates a physical isolation or barrier. And you can rely on the physical controls to protect the network, and external threats must breach the physical barrier. If you have to have external connectivity, no control is the same as a physical isolation. Consider segmentation and need rigorous front door screening, which implies firewall screen. Wireless networks, they can be expensive to deploy and no need to run wires to the endpoints. Quick connectivity of multiple users. It's convenient, support mobility, and ubiquitous. But the wireless concerns are introduced new attack surface, require additional design consideration to mitigate attacks. Data is transmitted over the air and is accessible. Use encryption, consider segmentation, and require VPN. Networks can be directly accessed from a distance. Internal and external network issues. Malicious code could be either an internal or external network issue. Unauthorized software, definitely an internal network issue with users downloading unapproved software or installing unapproved software. Information leak, that could be both internal and external. Internal would be somebody sending something out with an email, and external would be a breach or a hacker coming in. Unethical employees, that's an internal network issue. Zero-day exploits are typically from the outside or software that's not patched and has a vulnerability, so that could kind of be internal also. And complex network infrastructures, that's definitely an internal network issue. Common network security components used to mitigate threats. Hosts and nodes. Firewalls, we use firewalls to segment networks and to protect interfaces. VPNs, we use those to use encrypted tunnels to get to internal corporate data, either internally or externally. We use VPNs. Proxy servers, network address translation, where we hide the real IP address through a translated address or a fake address. DNS, which is domain name system, it's associate a name to an IP address. Directory services, that's your username database. IDS IPS, which is an intrusion detection or intrusion prevention system, or network access control. Hosts and nodes. A node, any device on the network, includes client computers, servers, switches, routers, firewalls, anything with a network interface that has a MAC address. Media Access Control Address, commonly referred to as the MAC address, or the MAC, is a 48-bit physical hardware address of a network interface card, NIC, as it's commonly referred to, assigned by the manufacturer. A host, a form of a node that has a logical address assigned to it. It's at the network layer, which includes clients, servers, firewalls, proxies, and routers. It excludes switches, bridges, and other physical devices such as repeaters and hubs. Firewalls, tools designed to stop damage, may be either a hardware device or a software product, deployed to enforce the access control policy or on network communications. They filter network traffic for harmful exploits, incursions, data, messages, or other events, and they protect networks against numerous threats from the internet. The throughput or bandwidth of a private network, so resources are available to authorized users. And firewalls are an essential component for both host and network security. VPN, Virtual Private Network. Mechanisms for establishing a remote access connection across an intermediary network, often over the internet. They are used for remote access, remote control, or highly secured communications within an untrusted network. Use tunneling and encapsulation protocols. Tunneling protocols encase the original network protocol so that it can traverse the intermediary network. Employ encryption so that the original data traverses the intermediate network securely. allow for cheap, long-distance connections when established over the internet. You can think of a VPN as you write a letter to a friend, you take that letter, you fold it up, and then you encapsulate it, you put it in an envelope, and then you address that envelope to the far end of the network or to your friend, and then as it traverses the mail system, that is in data is encrypted inside the envelope so people cannot see or read into that what that letter is written about as it traverses the mail system. When it gets to the other side, it decapsulates, unpacks it, and then delivers it to the host. So think of VPN as just that. That's the security. Proxy servers. They are a variation of a firewall, acts as a middleman between the internal client and the external server, hides the identity of the original requester through the server through network address translation, or NAT. Content filtering, they focus on the address of the server or keywords in transmitted content. It's a caching server, a data storage mechanism. Network address translation, or NAT, converts internal addresses into external public addresses and vice versa. It performs conversion of packets entering or leaving the network to mask and modify the internal client's configuration. Prevents external entities from discovering the internal internet protocol or the internal IP address and network configuration details. Reduces the need for leasing a significant number of public IP addresses from an ISP or internet service provider. It enables the use of private IP addresses while still supporting internet communications. It allows the extended use of IPv4, translate addressing schemes between IPv4 and IPv6. Here's an example of the NAT functions. The example pathway from the internal client to an external server. The internal client has an IP address of 192.168.12.153. The source port, which is important, is 13.571. As it goes through the firewall, it gets translated to internal 192.168.12.1 to an external address, which is routable across the internet, as 72.254.249.76. The NAT proxy firewall internal address is 192.168.12.1, and the external is still showing 72.254.249.76. So you can see how, as we talk across the network, the real IP address of 12.153 is hidden from the far end. Inside the firewall in the middle is a translation table that keeps track of that and knows and maps those connection points from the inside to the outside and outside from the inside, vice versa. Domain name system is the essential element of Internet private network resource access. Users' access to the file servers relies on DNS names to resolve fully qualified domain names, which are FQDNs. Without DNS, users would need to maintain a list of IP addresses of sites they wanted to visit. Is the foundation of most directory services in use today, such as Active Directory and LDAP. It's a non-authentication query-based system and uses plain text communication. There's a process that DNS works on. It's called DORA, just like Dora the Explorer, D-O-R-A. You can look that up. Directory services. A network index helps users locate resources within a private network, responsible for keeping track of which servers are online and which resources that hosts share within the network, such as printers, laptops. Users operates much like a telephone book does for phone numbers and addresses, an essential piece of modern networks that does not provide obvious security services, needs protection provided by other security services and devices, limits access to authorized and authenticated clients and users of the local network, which is a lot of language to say it's the database for the users and the computers on the network. Intrusion detection systems and intrusion prevention systems. IDS, a system that watches internal hosts or networks for symptoms of compromise or intrusion, and it complements the firewall. IPS strives to detect and attempt to attack or intrude to prevent the attack. The first layer or initial layer of defense. The limitations of IDS and IPS may not be able to detect zero-day attacks or false positives. So what we're saying is IDS is just like the commercial where the bank's getting robbed. IDS says, hey, you have an attack going on, just letting you know. And then the IPS says, hey, we have an attack going on, and you can configure an IPS to be proactive and make changes to the network to prevent and stop that attack. If you don't configure it correctly, you can lock yourself out of the network. So yes, that is a limitation, that either one of these are more reactive in nature. In anything 0 day, which means something not known, then it will not pick that up and block. And both of these IDS and IPSs are usually signature based or anomaly based, or a combination of those, of how traffic is coming across the network. Network access control limits the access or admission to the network based on the security compliance of the host, ensures all hosts connecting to the network have a current and compliant security component, blocks or restricts access to if a computer does not have the latest antivirus to update, a certain security patch, or a host firewall, or if the device is unauthorized. It enforces host hardening rules through an automated system-wide mechanism, meaning if you've got NAC configured in your environment and a computer that's not registered to your network comes onto the network, it's going to do a posture assessment. It's going to look at the operating system, the hardware, and the antivirus, and if it doesn't meet the minimum that you've supplied as what these are the basic minimums to get on my network, then it's going to send it off to either correct itself or deny access, depending on how you have it configured. TCP/IP basics, the knowledge of transmission control protocol and internet protocol benefits the security administrator in the following areas: firewall management, routing and switching, maintaining availability, improving network performance, managing network traffic, analyzing protocols, understanding vulnerabilities and exploits, performing penetration testing or ethical hacking. Most networks include the internet use of TCP/IP. Internet Protocol versions 4 is the most prevalent version in use. Internet Protocol version 6, IPv6, is gaining wider use. The OSI reference model, which please understand that this is a reference model. It's not exactly how it works, but this is how we can translate what's going on the wire from computer to computer as applications flow, so we can understand how to and where to look for troubleshooting. The 7 layers are starting from the bottom, physical layer, and that's bits and bytes of data. It's also the physical medium of either the copper patch cable or the light going across the fiber. Data link layer, which is a frame. Network layer, which is a packet. And transport layer, which is segmentation or segment. A session layer, which is the and presentation layer and application layer is where the application gets presented to the end user. And when you hit send, you're going to Google or some other application, you're going in reverse. You're going from application, presentation, session, transport, network, data, physical. And then you go across the wire, and then when it gets to the other computer, it goes right back up the stack. As a network and security administrator and a system engineer, we usually are responsible for the first 4 layers. And if you're paying attention, layer 3 and layer 4 are closely intertwined with protocols TCP and IP. Subprotocols. Here's the protocols and some of the what you kind of really need to understand from a network security administrator and what their function is. IP. IP encompasses both TCP and UDP, or any protocol gets rolled up under IP. If you break out TCP, which is the Transmission Control Protocol, it's a connection-oriented protocol, and User Datagram Protocol, UDP, is a connectionless protocol, and they all operate on the TCP/IP basis. There's other protocols too that we kind of are concerned with as a network or network security administrator, which is ARP, which is Address Resolution Protocol, ICMP for like ping, which is Internet Control Message Protocol, HTTP, which is the web, port 80, it's Hypertext Transfer Protocol, and then the secure version of that is HTTPS, Transport Layer Security, which is TLS, and that's you use TLS in your browser for security. And the headers and payloads. Packet filtering often focuses on four main headers. The Ethernet header of the frame is assigned to the data link layer, and the IP header of the packet from the network layer, and the TCP header of the segment is a segment from the transport layer, and UDP header is a segment of the transport layer. Filtering on addresses. IPv4 and IPv6 addressing issues. Well, the address length of an IPv4 versus an IPv6 is different. IPv4 is 32-bit and IPv6 is 64-bit and on hexadecimal, and IPv4 is binary with 4 octets. Available address capacity to meet the need of a unique addresses, which IPv4 public IP addresses are exhausted. It's hard to find those if you want to go get one from an ISP. IPv6s are relevantly new out there, and depending on how you subnet, you can have thousands of addresses, and with IPv4 you use subnet masking to break up or segment networks also. Filtering may focus on the IP address or the port number to make a decision to whether allow or deny. These decisions on rules can focus on either the source address or the destination address, or likewise the source or destination port number. Firewalls may filter on whether an address is known or unknown. An address is known to be benign or commonly sends malicious content, a variation of known and unknown filtering. An address which is real or spoofed. In summary, network security and the 7 domains of a typical IT infrastructure. We've explored some network security goals, internal and external network issues, network security components used to mitigate threats throughout the IT infrastructure, and the basics of TCP/IP.